Okay, ladies and gentlemen, we're going to talk about a different type of topic. It's called the arithmetic sequence. Now, if we look at the word arithmetic, it's a lot like the word arithmetic. Well, arithmetic means adding, subtracting. It's math. So using arithmetic to make a sequence. Well, a sequence is just a list or a group of numbers. Now, in this case, for an arithmetic sequence, if I take something like 2, 4, 6, 8, what would be the next two numbers in that sequence? Well, the answer here is, how did I get from here to here? I added 2. From here to here, I added 2. From here to here, I added 2. So therefore, from here to here, I probably ought to add 2. Now, 8 plus 2 is 10. So let's do it again. Plus 2 is 12. Now, I could keep on going. Right now, this is what we call a finite sequence, which means limited number of terms. If I were to do an infinite sequence, that would be an unlimited number of terms. And I could keep going forever and ever and ever and ever. And it makes sense because I could keep adding 2 and 2 and 2 till I turn blue in the face. So it's not that hard to see that you can go from a finite sequence, so say 1, 2, 3, 4, 5, 6 numbers, to an infinite sequence by going forever and ever and ever. Now, here's the other thing we need to talk about. This guy right here, and in fact each of these pieces is called a term. Now we might even call this A with a little 1 below it. A because it's arithmetic, and 1 because it's the first term. This would be A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. Now, so you'll notice we have the different little terms, and the different little terms depend on what number of term they are. Now, it doesn't have to be 2. See if you can do this example. 4, 7, 10, 13. What's next? Obviously, we're adding 3 every time. The reason we call it arithmetic is because we're adding terms. Now, by adding more and more numbers, we can keep making sequences. Now, just because we're adding doesn't mean that's the only type of sequence there is. Let's go with something more like this. If I go with something like 2, 4, 8, 16, now what's the next numbers? In this case, I'm not adding, because if I were adding, it'd be plus 2. But then that's plus 4, that's different, that's plus 8. That doesn't work at all. However, if I take 2 times 2, I get 4. 4 times 2, that's 8. 8 times 2 is 16. So 16 times 2 is 32. Times 2 is 64. And I could keep going again. These are called geometric series. And we'll actually talk about why we call those geometric series here in just a little bit. But the idea is you have arithmetic sequence and series, you have geometric sequence and series. Now, before we go any further, let's take a look at something slightly different. Okay, ladies and gentlemen, let's take a look if we have something like this. Now, in this case, we have more problems very similar to what we've been doing. But you'll notice they can get a little bit more difficult if we have decimals involved. The other thing that we can do, and a lot of times how we see series and sequence, is down here like this, where we have a table. In week 1, there were 7 laps. In week 2, there's 14. In week 3, there's 21, and in week 4, there's 28. So all I need to do to figure out for week 5 is say, what did I do to week 1 to get 7, 2 to get 14, 3 to get 21, 4 to get 28? The answer is 5 times 7 would equal 35. And with that, we can begin building series. Now, if we were to go down just a little bit, describe the relationship between each arithmetic sequence. This is where you have to determine, how do I get from one to the next, to the next, to the next, to the next. Here's a great example of a visual representation, because with one layer I have 3. With one layer I have 3, but with 2 layers I have 6. With 3 layers I have 9, so it makes sense. We just keep building and building and building. Now, with all of that, we'll talk about that in class. So what you need to be able to do is understand the concepts, and we'll talk a little bit more when we get there. Make sure you do the quiz.